All right. So we're looking at number 4. A passenger train leaves the train depot 2 hours after a freight train left the same depot. The freight train is traveling 20 miles per hour slower than the passenger train. Find the rate of each train if the passenger train overtakes the freight train in 3 hours. This one sounds crazy. There's so many moving parts. But don't worry, we're going to use the chart and we're going to break it down. I've got 2 trains, don't I? Yeah, I've got a passenger train and a freight train. So let's start there. Passenger train and a freight train. Going to set up my chart. Rate times time equals distance. My chart gets sloppier and sloppier as we go, I feel, but it's okay. All right. Let's break this down. Do I know the rate, the speed of the passenger train? Do you know it? No. I don't know it. I'm going to call it X. Or R, whatever you want to use. Now, it does say something about the freight train, though. The freight train is traveling 20 miles per hour slower than the passenger train. So if that's X, how would I represent 20 miles slower here? X minus 20, right? X minus 20. Now, here's where this problem gets a little tricky. Okay, you can't have a variable in both the rate and the time columns. Then how would you solve for anything? You can't. So I need numbers in here for the time. Let's see if we can figure out the time. All right, a passenger train leaves the train depot 2 hours after a freight train left. Okay, so the freight train, get this in our heads, what's going on here. I have a freight train that leaves. 2 hours later, the passenger train leaves, right? Then they travel for some length of time, and then at the end it says, find the rate of each train if the passenger train overtakes the freight train in 3 hours. So how long has the passenger train been traveling for? Read it again. Find the rate of each train if the passenger train overtakes the freight train in 3 hours. 3. The passenger train has been going for 3 hours. How long has the freight train been going for? 5. Because in the beginning it said that this guy left 2 hours ahead, right? So if he has been traveling for 3 hours, that means he's been on the tracks for 5 hours in total. Does that make sense? I know there's a lot of words in here and it's hard to piece through this. So once you fill in your chart, sometimes it's worth going back and rereading and making sure that you have all the pieces where you expect them to be. Okay? Because I guarantee you, people are going to swap them. They're going to have the 5 there and the 3 there, and that's not going to make any sense. So if you solve your equation, you're like, this doesn't make sense, go back and make sure that your pieces were in the right spot. Once you have these 2 columns, what do? Multiply straight across. So this is a 3x, and what's this down here? Minus 100. Now you have to ask yourself, are these 2 distances equal to each other? Or am I going to add them together and set it equal to some other distance that they gave me? They're equal. Do you agree with Maddie D? She says that the passenger train and the freight train have gone the same distance. I agree! Think what's going on. You have the 2 trains. They leave the depot. One's going. He's going kind of slow. 2 hours later, this guy leaves, going a little bit faster. At some point, they meet. Whenever that happens, isn't the distance they went the same? Yeah. So I set 3x equal to 5x minus 100. There's your equation. All right, and now you just solve. Minus 5x minus 5x. Negative 2x equals negative 100, so x must be 50. What did x stand for again? The rate of what? The rate of the passenger train. I have it right in my chart. rate passenger train. The rate of the passenger train was 50, so the rate of the freight train was 30. And what did they want? Find the rate of each. So there you go. You have each of them. Okay?